RHS Pre-Calculus presents the Magic Unit Circle. Feel free to pause the video at any time to write down a formula, example, or consult with your own friendly neighborhood genie.
Once there was a boy named Peter who was busy working on his math homework. Try as he might, he could not understand what the unit circle was or what its properties were. Hearing his cries of frustration, a magical genie called WizKid came to the rescue. This is the lesson that he taught Peter. The unit circle is a circle with a radius of 1 centered at the origin of a standard xy coordinate plane. Since the circle is 360 degrees around, it can be broken up into smaller angles. These degree measures can be written in terms of radians as well. The conversion is simple. Pi degrees times y radians over 180 degrees equals y radians. Going the other way, y radians times 180 degrees over pi radians equals x degrees. There are a few basic reference angles. They are 0 degrees, or 0 radians, 30 degrees, or pi over 6 radians, 45 degrees, or pi over 4 radians, 60 degrees, or pi over 3 radians, 90 degrees, or pi over 2 radians, 180 degrees, or pi radians, 270 degrees, or 3 pi over 2 radians, and 360 degrees, or 2 pi radians. Moving counterclockwise around the circle. The ray of each angle intersects the unit circle at a point that can be found by taking the cosine and sine of the angle. For each point, the sine of the angle is the y-coordinate, and the cosine of the angle is the x-coordinate. Let's look at the angle 3 pi over 3 radians. Start by drawing a perpendicular line from the point where the angle's ray intersects the circle to the x-axis. The radius of the circle is 1, so the hypotenuse of the new triangle is also 1. Since pi over 3 radians is equal to 60 degrees, we know that the triangle is a 30, 60, 90 triangle. Knowing this, we can use the 30, 60, 90 triangle shortcuts to find the base of the triangle is half the hypotenuse. In this case, it is 1/2, and the height of the hypotenuse times the square root of 3 over 2. In this case, it is the square root of 3 divided by 2. Using SOHCAHTOA, we know that sine pi over 3 equals the square root of 3 over 2, which is the opposite side, divided by 1, the hypotenuse, which equals the square root of 3 over 2. We also know that the cosine of pi over 3 equals 1/2, the adjacent side, divided by 1, the hypotenuse, which equals 1/2. In other words, the x-coordinate is 1/2, and the y-coordinate is the square root of 3 divided by 2. The other trigonomic functions, tangent pi over 3, cosecant pi over 3, secant pi over 3, and cotangent pi over 3, can be found using the triangle and/or the reciprocal and quotient properties. Peter was in awe. He actually understood what the WizKid said. Peter was so happy that he could hardly contain his excitement. Now he could finish his homework. "Thank you, WizKid," exclaimed Peter.